Okay, for today, this is a sequence and a series unit. What in the heck is the difference? Well, a sequence is something you've done before, and that's just like a list of numbers, okay, in a row. And does anybody know what is going on here? This is just a dumb little puzzle thing. Don't worry, this isn't super critical. Yes? Okay. O is 1, T is 2, T is 3. Sorry. F, wait a minute. F is 4, yep, so what will be the next one? F is 5. And then 6 would be S. All right, so, yeah, that would be good. At least it was not on your desk, so. All right, so obviously this is not the kind of sequence that we are really going to be doing. What we are really going to be doing is things like that. That looks a lot more scary because we're in pre-calc, and it can't be as simple as last year. Last year you did sequences. You never did series before. A sequence of numbers is just like 2, 4, 6, 8, 10, or 2, 4, 8, 16. See what I'm doing there? 32, and that's exponential growth versus just linear. Okay, or arithmetic versus geometric. All right, so the biggest challenge for today is trying to figure out how these little systems will generate a list of terms for us. You can write something fancy-dancy like this that will get you the even numbers. 2, 4, 6, 8, 10, 12, 14, 16. You can write a fancy sequence for that, and you will before the end of the hour. All right, so let's make sure you understand how these generate terms. If it says n is greater than or equal to 1, what would be the logical thing to start with? N equals 1. Would you please, in your head, just in your head, stick in a 1 wherever you see n, and it turns into 5 to the 0. What is 5 to the 0? 1 over 3 to the 1, which is, what's 3 to the 1? 3. So then it's 1/3. That was the first term. Now figure out the second term. Now write out the first 4 terms. Now let's put in 2. Just to clarify, you don't use like 1.5. So the next term we're going to put in is n equals 2. You put a 2 here. 2 there. 5 to the 2 minus 1, which is the same as 5 to the 1, which is 5, over 3 to the second, which is 9, 5/9. 5/9 was the second term. Raise your hand if you got that too. Okay, let's get the third one. SH. Know who that is? I know who that is. Five to the third. Oh wait, 5 to the 3 minus 1. 5 to the 2, which is 25 over. Keep going. 27. Thank you. So 25 over 27. Now that is a sequence. Now, is it going up by a nice, simple thing? So you're saying you can't just multiply the top by 5 every time and multiply by the bottom by 3 every time? Think about that. Do you get that the top is just multiplying by 5 each time and the bottom is multiplying by 3 each time? Is that the same as multiplying by 5/3 each time? Yeah. If you take this and times by 5/3, do you get that? And then if you take 5/9 and multiply by 5/3, do you get that one? Yeah, so it's just times 5/3 every time. That was a geometric, because you're multiplying by something each time. Were we adding something each time? No, that would have been arithmetic. This one was geometric. All right, that's pretty gruesome. It's scary stuff. It's not that bad, though. Once you have a list, if I gave you this list, 2, 4, 6, 8, you'd be like, that's easy. I can tell the next ones. You know what I'm saying? So you just have to make yourself a list and use this little thing to make yourself a list. in this case, I know you've never seen this before, but I bet you could predict. What do you think I'm going to have you stick in first? 1. And you keep sticking in numbers until you would get to infinity. But obviously, we're going to stop before then. We're going to just do 4 terms. Okay, so we're going to put in a 1. And do you get that that is 2 minus 1, which is 2?
What?
Very good. Then we're going to put in 2. And that's going to be 4 minus 1, which is 3. And then we're going to put in 3, which is 6 minus 1 is 5. Oh my gosh, what have we got there? A fancy way to write the odd numbers. All right, I'd like you now to go the other way and tell me what the even one would be. How could you make one that would give you the even numbers? It's really not that complicated. You just want it to be 2, 4, 6, 8, 10. Just adjust that little formula. Do you see it? Raise your hand if you see what we could do. 5 people. SC, what do you think? Yes, you could, but there's an even easier way. Who sees something I could do that's easier than changing it to subtract 2? Yes. Yeah, so just get rid of this. Your way would have worked, absolutely. The only problem with that way was it would have started with 0, and we usually start the odd numbers with 1, or the even numbers with 2. All right, so if you put in a 1 now, do you get you're going to get 2? And then you put in a 2, you're going to get 4. And you put in a, yeah, I think you get the idea. Okay, so what did we learn at school today? A really fancy way to write a formula for generating the even numbers, or the odd numbers. All right, how about this next one? Whew, really scary looking notation, but in the end, it's just going to be something like 3, 6, 9, 12, you know, not super hard. Try to figure out what the very first term of this thing is. Does anybody know yet what the first term is? Yes, 7 is correct. What's the second term? Somebody said -5. Do you agree with them? Anybody want to jump on that train? A lot of people are not sure.
Yeah.
Some people think it's 0. You can tell by hand motions. Mr. I think it's -5 guy. Tell me what your reasoning is.
Well, A sub n is 7 right now.
This is A sub, you're saying this is A sub n?
Well, it's A sub 1.
Oh, it's A sub 1. Okay. It does say that right here, so I can't argue with that. A sub 1 is 7.
So the next term, which is set by A sub n plus 1.
So this is, you're saying that's saying the next term.
And the last thing says n is greater than equal to 1. You can start that with A sub 1.
So it says that n is greater than or equal to 1, so therefore n equals 1 would be the first thing you would stick in.
And then 2 minus A sub 1 is 7.
So this is 2 minus A sub 1, which was defined as 7. And then it's 2 minus 7. And what is 2 minus 7? -5. Now that was a really complicated nest, but you're right. Now can you tell me what we're just going to do each time? So what do you think the next term would be? Because why? So now you're going to go 2 minus the one before it. So you're saying to get the next term, you do 2 minus the one before it. So if I do 2 minus the one before it was -5, that's going to be 7. And then I'll have 7 here, and I'll go 2 minus the term before it, which would be -5. And you're right, it's just going to alternate back and forth between 7 and -5. I know, that's a tricky one. Okay, so let's see if you can handle a more normal one. Let's say I go Just give me the first three terms of that. Three n plus 4. There's an n here, and that's just a 1, and that's an infinity. We just did one like this a minute ago. So when you put in 1, you would put in 1. I'm going to write n equals 1 down there. Maybe that'll help. They don't always, but that would be implied. Okay, now I'm going to start with 1. I stick in a 1, and I get 3 plus 4 is 7. Ooh, it starts with 7 again. Winter, tell me what to do next. All right. So if you stick in a 2 right here, then you'll have 10. Does it seem like we just added 3? Yeah. You get, if you think of this as backwards, as starting with the 4 and then adding 3 times the number. You just started with the 4, and you keep adding 3 times the number. So then that means you're going to add 3. Every time this goes up 1, you're going to go up another 3. So I can just start doing them this way in my head a lot faster and just say, oh, it's just add 3, add 3, add 3. All right, so here's some terminology that you're going to need to be able to do. It's going up by something each time. That's called something. From last year, the common difference. The difference between each one is 3. The common difference is 3. Now, if this had been one where you were multiplying and it was going up, that would be called a common ratio. Does that ring a bell? All right, so if it was going 2 and then double that, or no, let's go triple. 6, triple that, 18, dot, dot, dot. Then this, the common ratio, would be 3. If you take this divided by that, you can tell what the common ratio is. If you do this minus that, you can tell what the common difference is. Common difference, 3. Common ratio, 3. That's an example of common difference, common ratio. Okay, so let's try this one. I'm starting with 10. I'm going to add 4 each time. Anybody tell me what should go in there? Don't say it. Try to figure it out. What formula could you write that would make this work? You'll know if it works, because when you put in 1, you'll get 10. When you put in 2, you'll get 14. When you put in 3, you'll get 18. Get the idea? So who can give me one that at least when you put 1 in, it gives you 10? Well, you could do a lot of things. I could go 3 times the number plus, let me see, 3 times 1 is 3, plus 7. That'll make a 10 for the first term, but it won't work for any of the other terms. You know what I'm saying? All right, so that's a way you can start playing with it. And then you go, but I want it to go up by 4 each time. Oh, maybe I shouldn't use a 3 n. What do you think? Can you do it? And you don't sound super confident, but I think you might be right. How would I tell if you were? Okay, so we put in 1 in the first place just to make sure it equals 10, and it does. Cool. What if I put in 2? What do you think we get? 2 is 14, and that's the second term. Looks like it's working. Let's try 3. 4 times 3 is 12, plus 6 is 18. I think you've got it. All right, so that's writing a term generator is the way I'm going to refer to those. Okay, now I want to show you one more format for these, but this is slightly different. No, you know what? I'm realizing I'm not going to, I went a little too far last hour. I taught them You know, I'd like to pre-teach, kind of like get you ahead and like show you the big picture, but I think I got them lost. So I'm not going to go quite as far. So, all right. So instead of getting you lost, how about if I just get you really good at this kind? That's 3 terms in. Do you get, if I wanted to get like 5 terms in, I could just keep adding 4, but there must be some smarter way to figure out the 5th term. Would you agree we're adding 4 each time? And that's called the common difference. We're going to denote that with a D. Then there's a way to predict what the 5th term is. Amount sub 5 would be the original amount, which, by the way, sometimes they call A and sometimes they call it A sub 0. Okay? So get used to, it's annoying, but some of the formulas have just an A. Some of them have a sub 0 for the starting number. Okay? What would I do to get to the 5th term? I'd start with the 10, and would I add 5 4s to it? You know what I mean? We're going to add 4 a bunch of times, right? If I want the 5th term, do I add 5 4s? No, I don't. I'll give you this example. Let's say I just wanted the 3rd term. You guys all know that the 3rd term is 18, right? How many 4s did I need to add? To get the 3rd term, I needed to add 2 of them. So, does anybody want to finish and tell me what they think this formula should be then? If n is the number of terms I want, is it just like a plus n? No. WG. A sub n minus 1 plus 4. Oh, a sub n minus 1 plus 4. So, but you don't, okay, so you're saying if you want the 5th term that you're going to do, I like the idea with the minus 1, but that's saying that you should just take the 4th term and add 4 to it. I can't argue with that, but you can't just directly find it. To find the 5th term, you'd always have to find the 4th term then. Know what I mean? So if I want to eventually be able to find the 25th term, I don't want to have my rule be find the 24th term and then add 4 to it. You know what I mean? So your way works, but there's going to be a way that just gets you the answer directly instead of having to figure out the term right in front of it. It has to do with A, the starting term, which is in this case 10. It has to do with N, and it has to do with D, the common difference. I'm going to give you a minute. I want you all to come up with your best concoction. Some of you might already have it. Awesome. Write it down. Make sure it actually works. Find the 5th term with your little formula that uses A and D and N, meaning N, I'm going to use a lowercase n, N for the number of terms. D is the common difference. A is the starting term. N is the number of terms. How can you predict any term? Well, you take the starting term, which is A, and then you what? Any term, I'm going to call it A sub n, the nth term, would be the starting one, and then, well, you'd have to add the common difference a bunch of times, right? So can I just say plus D? No, that wouldn't like account for how many times I have to add it, right? How many times do I add D? What do you think the answer is, sir? So where do I put that? And I already have the plus A at the beginning. Do you want another plus A? Okay, all right. Then Prove to me that yours is right. So let's just use yours to find the third term. Okay? So I don't need you to do it on your paper. Just tell me verbally how to prove that it works for the third term. Okay, so what should I do? What do I put in? Okay, so n is 5. How about we start at the beginning of your formula here? A sub third term will be, what's A? 10 plus, what's D? Times 5? Minus 1. Now, does that really equal 18? No, I asked him to prove that this would work for the third term. Okay. Thank you. Now do you feel like that's going to prove that your formula works and gives us 18? All right. So what's this? Times 4 is? Plus 10 is? 18. It seems to work. So then, if you're right, I'm not saying you're wrong, then tell me what is the fifth term, or tell me how to use your little formula that you just said to find the fifth term. Okay, so we're going to say A sub 5, amount 5 is a way to think of that, okay, would be equal to, why is 4D? I'm not saying you're wrong, I'm just asking. That's the difference each time. Okay, keep going. So this would be 4 times 4 is 16 plus 10 is 26. He's right. And that is the formula. All right. A plus D times n minus 1. Let's use that formula in a typical question from the test. Down the road, here's what we'd expect you to be able to do. 6, 9, 12, ... If 6 is the first term in this sequence, what's the 10th term in the sequence? What's the 10th term? So you're using this to find the 10th term. Kind of conflicted on who to call on, so I'm going to just let the dice of destiny pick. Row 3, first person. Miss W. Yes, please, for sure. You're finding the 10th term and you started by? All right. And I'm going to just say A sub 10 and 6. The difference was 3. And then how many of those differences do you do? Close. 10 minus 1. Okay, there you go. Which makes 9 of those differences of 3, which makes 27, plus 6, which makes 33. Raise your hand if you had 33. Okay, awesome. All right. Excellent. Get to this slide right here. You should be able to answer it. Like, easy peasy. I'll pause for a second while I give that a try. All right, so what's the sixth term? 1, 2, 3, 4, 5. Let me see, sixth term. Well, I'm going to use that formula I just was told by the teacher. A plus D times n minus 1. That was the formula, right? So then A is the first amount, so that's 2, plus the difference every time was it was going up by 4, it appears, times n minus 1. If I want the 6th term, I want 6 minus 1 is 5 of those. Think of it this way. This spot right here is the 3rd term. I didn't want to add 4 3 times, only 2 times to get to the 3rd term. That's why it's 1 less. If I want the 4th term, will I add 3 times? Yes. To get to the 4th term, I would go 3 times. I would not add it 4 times. All right, so then that's why it's the n minus 1. So then this is 5 times 4 is 20 plus 2 is 22. Raise your hand if you had 22 for that one. Good. I hope you didn't do it by just like, okay, add 4 again. I know, that's quicker in the short term. But by the time you got here, it would be really getting ludicrous. You'd just be keeping adding 4, add 4, add 4. I hope you did this by 2 plus 4 times, and again, what 20th term? So then I want 19, and then 4 times 19 plus 2. All right, so let's see. 4 times 19, that's pretty much like 5, or like 20 times 4, which would be 80, but then I could subtract off 4. So that'd be 76 plus 2 more, 78. Did you guys get 78 for that one? Okay, good. And then last but not least, the nth term. Ooh, that's kind of cool. I'd start with 2 plus 4 times n minus 1. Oh, that's the equation that I've been using. Okay, so how about, that's the big formula we've already established. How about this other formula, the big formula, geometric? Here it is. Instead of like making you develop it, I'm just telling you. You didn't need to know that one. This test, out of all the tests this semester, is the one that leans more on formulas than anything else. You got a lot of formulas. That's a good question. There's a little bit of a battle that goes on. I'm in favor of memorizing some more formulas than some people are. And some people think we should just give you all the formulas. And I think it might be a combination of the two. The reason I think that you'll be better if you have them memorized, not all of them, is that I think if you have them memorized, you can use them a lot better than if you just have them on a sheet. But some of them are pretty gruesome, so we'll probably do a combination of the two. Some of the formulas are just really long and painful, and you wouldn't remember them any more than, for the test. So we'll probably give you some of these formulas, but I'm going to say I don't think that we're going to give you the easiest ones, like this one, because you can memorize that. That's not that hard. All right, so I want to give you one. Let's say it goes 2, and then triplet is 6, and then triplet is 18. Then what's the 4th term? And please don't just triple 18. I know you could, but try to use this little formula. All right, so if I'm going to find the 4th term, then what's A? 2. What's R? 3. It's the common ratio. If you ever have trouble finding it, because sometimes we aren't giving you nice numbers. It's not just like times 3. You go this divided by this. That'll tell you what the common ratio was. And if you want to make sure it actually is that, you take this one divided by that one, and it better be the same thing. Okay, so R is 3, and then it's n minus 1. What is my n? If n is 4 for 4th term, I do 4 minus 1. So that's 3 to the 3rd is 27. 27 times 2, 54. I think I did that right.
Yeah.
Okay. All right. Then I know you may not be able to do this in your head, but tell me what you'd type into the calculator if you needed the 10th term. A for amount is our starting amount, and you should have said 2. And then we're assuming we're still doing the same problem where we're timesing by 3. So then this is a 3, and then it'd be to the what? To the 10 minus 1, which would be to the 9th. Yes, 2 times 3 to the 9th. Raise your hand if you knew that. Okay, awesome. Then you've learned everything you needed to for today. Yeah, but I'm just wrapping up here. So this is the part where I'm going to give you the homework. We'll do some of it together. This is classwork, meaning that we could do some more practice problems, but I'm feeling like we're near the end here. So here is your homework. You're going to do this one. It's kind of a weird one. It starts at 117. And then the next term you do 1 over that. And the next term you would do 1 over that. What happens when you do 1 over something? It flips it over. If you have 117, what's 1 over that? What's 1 over 117? And what happens to do 1 over that? 1 over 117. What is it then? 117. What about 1 over that? 1 over 117. Yes. All right. Good enough. Moving on. Then I want you to do these that I have circled right here. And that's it.